Guys, let's look at this problem right here. This question is asking Spaceship A leaves Earth at a speed of 0.5 c with respect to Earth and travels in a straight line towards a distant star. 10 years later, Spaceship B leaves Earth on the path as Spaceship A, traveling at 0.7 c with respect to the Earth. In the reference frame of the Earth, how long does it take Spaceship B to catch up to Spaceship A? Now let's draw a diagram for this one. Here we have A, it's already traveled 10 years, okay, 10 years with speed of 0.5 c, and after 10 years this B is starting. This is our A, this is A, and after 10 years this B is starting, and this B is traveling with 0.7 c, okay, and after certain time this is going to catch up this A. The distance is going to be equal at the time, right? And that time is the question. To find that time, what we are going to do is we are going to equate the distance, because we know that when they meet each other the distance is going to be equal. So from that one we can create the equation. In the first one we are going to have dA is equal to dB, and we know that distance is equal to speed times the time, and dA, let's call the speed of A is VA. So VA times 10, because it's already traveled 10 years, so 10 years plus it's going to travel some additional time, because if it start after 10 years it's going to take a little time to catch up, right? So it's going to take a little time. That time is going to be, let's call that one T. So VA times T, and that's going to be equivalent to VB times T. Here the T is what we are trying to find. In order to find this one we are going to rearrange this equation. If we bring this VAT to this side, this is going to become VBT minus VAT, and that's going to be equivalent to VA times 10 years. 10 years. If we take T common, this is going to be VB minus VA, and that's equivalent to VA times 10 years. 10 years. Therefore, T is going to be equivalent to VA times 10 years divided by VB minus VA. Okay, now let's go ahead and plug the values. First we have VA is traveling with 0.5 c times 10 years divided by VB is 0.7 c speed minus 0.5, and that's 5c, and that's going to give us 25 years. So VB is going to travel, this B is going to travel 25 years to catch up this A. Okay, and let's look at the B part. In the B part they are asking, in the reference frame of Spaceship B, how long does it take? So to find this one we are going to use the time dilation equation. That's given by T is equivalent to T naught gamma, and gamma is given by 1 over square root of 1 minus V square over C square, and T naught remains on the top. So this is equal to T, and we know the relativistic velocity, like reference to Earth, that is given by, we found out that one, that's 25 years. We are trying to find T naught, that is the reference frame of spaceship, the time in reference frame of spaceship. Okay, so that's going to be T naught. T naught is going to be equivalent to 25 times square root of 1 minus V square over C square. In our case B is traveling with 0.7 c, so this is going to be 0.7 c whole square divided by C square, and if you calculate this one you are going to get 17.85 years. So in the reference frame of Spaceship B, it's going to take 17.85 years to catch up, and that's how we do this kind of problem. So I hope this helps. Thanks for watching.